Okay, Oak Rovers, this is going to be a video that's going to help you in your Algebra Connections book, section 8.1.3. And the name of this section is called Factoring of Special Cases. Now, number 22 is just like what we did on the homework number 16 from the day before. And I kind of have a video. You need to watch that to make sure you're doing that correctly. So make sure you watch video for problem number 16 before you actually come to this classwork. And make sure you did it right, correctly. So the first problem, what you have is you have four different quadratic expressions and you have to factor them using a generic rectangle and diamond problem. It's just like what I did on 816. So if you have any questions, go back and look at that again and make sure you understand it. If you don't understand it, you need to see me before you start up on these problems. Now, not all these problems are going to be factorable. So there could be that one of them, if you're struggling with, it's just not a factorable expression. Okay? Next part of the problem, I put the math meanings and methods down next, and it says standard form of a quadratic. And I want to talk about what that means. Standard form of a quadratic expression is in the form of ax squared plus bx plus c. And that's what standard form is. And it says notice that the terms are in order from greatest to exponent to least. So I start with my x squared term, then my x term, and then my units term comes last. And that's what it means to be in standard form. It's got to be going from greatest exponent to least exponent, from left to right. Examples of quadratic expressions in standard form are 3m squared plus m minus 1. That one's an easy one to see that that's in standard form. But they also say that x squared minus 9 is also in standard form. It's missing that x term, but that means that b is equal to 0, because if b is equal to 0, 0 times x is going to be 0, and it's going to be eliminated. So that's what that kind of means there. This last one, it says 3x squared plus 5x, and that's also in standard form. But in this case, c is going to be equal to 0, because there is no units term for that problem. Okay, let's go on to the next problem. Number 23 is our special cases. And it says most quadratics are written in the form ax squared plus bx plus c. But what if a term is missing? Or what if the terms are in different order? Consider these questions while I factor the expressions below. Share your ideas with your teammates and be prepared to demonstrate your process to the class. So what you're going to do with these guys, you're still going to use a generic rectangle and diamond problem. Now, when you're making for letter A, for example, when you make your generic rectangle and diamond problem, if I put my 9x squareds in the bottom left, so I want you to picture that, go ahead and do that, and then your negative 4 in your upper right. Now there's no x term. That doesn't mean that you're going to put zeros in for these numbers. What that means is the sum of these two boxes in your upper left and your bottom right has to be 0. It still has to have a product of negative 4 times 9x squared, which is negative 36x squared. So you have to have a product of negative 36x squared on your diamond problem and a sum of 0. See if you can find the two numbers that have a product of negative 36x squared and a sum of 0, because those are going to be the numbers that you put in your upper left-hand corner box and your bottom right-hand corner box. Okay? Hopefully that'll help. Just remember, if there's no x term, there's going to be in the nothing in the bottom left-hand corner, like for D, but there's still going to be a 40 there. And these two things have to add up to negative 100. So you're just going to do them just like normal. And if you have questions on them, we'll talk about them a little bit tomorrow. Let's look at the next problems here. The next one, in order to do this problem, you're going to have to factor out a number from this quadratic before you actually do the factoring of it. So this one, you're going to factor something out, then you're going to put what you have left after you factor that out in your diamond problem and generic rectangle. The last problem, you're going to have, it's like a table. So if you multiply x plus 7 and x minus 2, that's going to go in this box right here. Then if you have x minus 2 as one of your factors, what gives you a product of 3x squared minus 5x minus 2? So what I would probably do is build generic rectangles for these problems and see what you can kind of do. Again, I'll talk about these a little bit tomorrow if you have questions. Hopefully that helps, and we'll see you tomorrow.